Hello, Asad. How are you doing?
Hello, Mr. Anil Kumar. I'm doing good. Thank you.
Well, for the benefit of all my viewers, I'm Anil Kumar from Toronto, Canada, and Asad is my student. He had asked me a particular question regarding increasing and decreasing interval of functions. He's doing calculus at present. We can actually find increasing and decreasing intervals by analyzing the first derivative of the function. Before we begin with sample examples and the particular question which Asad is interested in understanding, let me first introduce you to Mr. Asad. So, Asad, can you introduce yourself?
So hello, everyone. My name is Assad. I'm from Uzbekistan. I'm currently studying calculus, and we're going to be going over intervals today. And yeah.
Great. So, Asad, based on your question, I actually prepared a lesson with a couple of similar examples. So, we'll go from simple examples to the question which you asked so that the whole concept is absolutely clear. So, let me share with you the screen, the video which I have prepared for you. Okay, so we can actually start with this. So, so here are two questions which we are going to answer today. Question number one is find the value of x for which the function f of x is decreasing. And here I have taken four functions as you can see. So part A is f of x equals to x squared minus 4x. B is f of x is 2x minus x squared. C is f of x is x plus 16 over x. And D is f of x equals to square root of x plus 4 over square root of x. So in question number one, we need to find the value of x for which the function f of x is decreasing. Actually, it should have been the values, and it is basically the interval which we are interested in, right? So we are actually interested in the interval. So truly speaking, the question should have the term as find the interval during which the function f of x is decreasing, okay? Now, related to this, we have question number two, which is the function y equals to x squared plus bx plus 10 is increasing in the interval minus 2 to 2. Find possible value of b. Correct? So these are the two questions which we are going to discuss. And Asad, your question was related to part D of question number one, correct?
Mhm.
Now, how do we find increasing or decreasing interval of a function? Asad, can you tell me from your knowledge of calculus?
Mhm. Um, Sorry, Mr. Anil, can you repeat that question?
How do you find increasing and decreasing interval of a function using the concepts of calculus?
So we can find the values of x for which the function decreases and increases by trying to get the derivative of the function using the first
Correct.
derivative and the second derivative.
Correct. First derivative is enough. You are absolutely right. So the concept here is that the function is increasing in the interval where the first derivative is positive. So when you find the derivative actually gives you the gradient, correct? So the derivative gives you the gradient or the slope. That is what derivative is, correct? So when you say dy dx, that means the gradient. And the gradient is increasing, that means dy dx or the derivative is greater than zero. That is what the concept is, right? So basically, for all the four functions which we have considered in question number one, we'll find the first derivative and then we'll analyze. So, so increasing is when it is greater than zero. Now, the function is decreasing if the interval is it is decreasing in the interval where the first derivative is negative. So definitely there will be some point in between where it could be undefined or zero, correct? Since it has to turn, correct? So this is the point where basically we have the first derivative equals to zero, correct? Horizontal. Or we have a point where the first derivative is we say does not exist, right? So these could be two different situations. So we could have a corner or we could have a turning point. So that is the turning point, or we could have a cusp or a corner when the derivative becomes from positive to negative or from negative to positive, correct? Now these points, as you can see here, can also give you local maximum or minimum also, correct? So remember this part. The analysis of first derivative, which we are going to do in this particular example, will help you later to understand how do we find local maximum and minimum for a given function, and also it is going to be very helpful in curve sketching. Okay, so these are the two things which is in future going to be uh, uh, very helpful once you understand these concepts. So in short, we can say that increasing interval is when the first derivative is greater than zero, and decreasing interval is when the first derivative is less than zero. So when we say interval, we're looking into the whole interval where the first derivative is increasing or decreasing to find whether the first interval is positive or negative to find whether the function is increasing or decreasing. Is this concept clear to you, Asad?
Mhm.
Okay, so we'll begin with the very first example, which is f of x equals to x squared minus 4x. Now, what kind of function is this, and what kind of graph do you expect when I sketch fx equals to x squared minus 4x, Asad? Can you tell me that?
So I think this will maybe make a parabola, maybe?
Yes, you're right.
Or
It's a parabola that opens up, correct? So let's look into
Mhm.
the very first question, which is f of x equals to x squared minus 4x. So clearly, this particular function is representative of a parabola, which will be kind of like this. So when we find the first derivative, what do we expect? We expect negative value for the first derivative in one interval, which is from left to the vertex, and then here we expect the first derivative to be greater than zero. But there is a critical point, which is right there, which is the vertex. Now, at this critical point, the first derivative is going to be zero. So, for us to answer this question, it is very important to find this axis. Now, this axis is the value of x at which the vertex will lie, correct? So this question could be asked in many different ways. So these are the different ways in which I have shown you the solution. Now here, let's get back to the solution directly. So the first derivative will be what? 2x minus 4. We are interested in the decreasing interval. Decreasing interval means that this derivative should be less than 0. So let us equate 2x minus 4 to less than 0. Taking 4 to the other side, we get 2x less than 4, and then dividing by 2, we get x less than 2. So therefore, it is decreasing in this interval where the value of x is less than 2. So anywhere from minus infinity to 2, the function is decreasing. Is this part clear to you? Perfect. Well,
Yes.
sometimes what we do is we may just write, well, within the interval minus 5 to minus 4. For example, it is also decreasing in this interval, correct? But the whole
Mhm.
range where it is decreasing is between minus infinity to 2. You can never include infinitely large values, but you could include 2 in this particular case, and therefore you see the square bracket, right? That means included, correct?
Mhm. Mhm.
So this is also a good convention to understand. Now the second example is also very similar to the first, the parabola, but this time 2x minus x squared represents a parabola which is opening down, correct?
Yeah.
So in this case,
Mhm.
the decreasing interval will be in the part which is after the vertex, right? So that gives you the concept. So once you have a function, try to visualize what kind of function it is and what kind of graph do you expect. That helps you to write down the answer, right? Now, the
Mhm.
process is exactly similar. What we have done here, we have found the first derivative, which is 2 minus 2x, and decreasing means this derivative should be less than 0. Equating 2 minus 2x to less than 0, we get 2 is less than 2x, or 1 is less than x. That means x is greater than 1. So any point between x greater than 1 will give you an interval which will be increasing. So the interval here is from x equals to 1 to infinitely large value. So we could give it as any interval. However, this is the general value of the interval in which the function is decreasing. Is that clear to you?
Mhm.
Perfect. So
Yes.
now Can you please read the later half, which I've written as a note, Asad?
hmm So note that the vertex of the parabola lies on the line of symmetry.
Yeah,
Graph of the curve decreasing on one side and increasing on the other of the line of the axis.
correct.
So
Equation of
equation
the
of
axis for y equals to ax squared plus bx plus c is basically x equals to minus b by 2a. So even without doing
mhm,
the calculus part, we could have found the solution of this question without calculus, right? Since it is just a parabola, just by finding the value of x, we know where, in which direction the graph opens. If it opens above, then the decreasing interval is from minus infinity to the axis, and if it opens downwards, then it is from the axis to infinity, correct? And the value
mhm,
of the axis can be easily calculated by equating x equals to minus b by 2a, correct? Is that concept clear to you? But this
mhm.
could be done with simple equations like parabola. Now let's get into the C and D part where so that is the graph which I have shown to you just to summarize. So what we really found is that the function f of x was x squared minus 4x over the axis of symmetry. And we found that this point where the derivative is 0 was at x equals to the value of 2, and it is decreasing in this interval from minus infinity to 2, correct? In the other case, we found that the axis was at minus b by 2a. You can also calculate minus b, which is equals to minus 2 by 2a, which is minus 2 times 2, right? So minus b by 2a. So let me rewrite this as minus x squared plus 2x. That becomes the function y equals to, so minus b means minus of 2 divided by 2 times a, which is 1 minus 1, correct?
Oh, yeah. So x
So
becomes
minus
1.
b by 2a, right, by 2a, correct. X equals to minus b by 2a, right? So here b is equal to 2 and a equals to minus 1. Substituting these values, we get this value of 1, right? And therefore, this is at 1. So from 1 to infinity, we see that it is decreasing. Do you see that? So that is without calculus also, you could have found your answer. Now, let's get back to the other two questions, which incorporate the rational functions. Now here we have the function f of x equals to x plus 16 over x. You need to find the derivative, right? So what is the derivative of x plus 16 over x? Derivative of x is 1, and this is like x to the power of minus 1. So that gives you minus of x to the power of minus 2, which could be written as 16 over x squared with a negative sign. Is that clear to you?
Mhm.
Right. Now, to find the decreasing interval, we'll equate this derivative to less than 0. So when you have a rational function, it is a good idea to have a common denominator, right? And then factor numerator and denominator. So we get x squared minus 16, which could be factored as x plus 4 times x minus 4 divided by x squared. And now that should be less than 0. Now, how do we do this? How do we find the interval in which the function is less than 0? Well, you need to find the critical numbers. The critical numbers are the numbers where the function is either 0 or undefined. So we have three critical numbers. One is at x equals to minus 4, which will give this factor x plus 4 as a 0, right? The other critical number is 0, which gives the factor x squared as undefined. And then we have 4, which give the factor x minus 4 as 0. So we have these three critical numbers. Now, these three critical numbers in a coordinate plane will divide the whole plane into how many intervals? Four intervals,
Four
correct?
intervals.
So they divide into
Mhm.
four intervals, intervals being from minus infinity to minus 4, and then from minus 4 to 0, and then from 0 to 4, and then from 4
4
to infinitely large
to
value. So
infinity.
these are the four intervals
Mhm.
in which the whole coordinate plane is divided. We need to just check the sign, and therefore we'll just take some test points. In each interval, I have taken a test point. In the interval minus infinity to minus 4, minus 5 is the point. In the second interval, from minus 4 to 0, I've taken minus 2. And then from 0 to 4, 2 is my test point, and 5 is the test point in the interval from 4 to infinity. Now, for each interval, we will test our factors. So these are the three factors which we need to test. The factors are x plus 4, x squared, and x minus 4. So we're going to test only the sign of these factors. So if I put minus 5, the first one is negative, and with minus 2, 2, and 5, x plus 4 will be positive, as shown here. X squared will always be positive, as shown, correct? As far as x minus 4 is concerned, it will be negative for minus 5 and minus 2, and also with 2. But when I substitute 5 in it, 5 minus 4 is a positive number. We're only writing the sign. We're not interested in the numbers, correct? Now, these are the size of the three factors. When you multiply them, we know if we have odd number of negative signs, then it is negative. In the first case, we have two negative signs, and that makes it positive, correct? So these two negative signs are even number, will make it positive. So the first interval, what we have is positive. In the second interval, we have one negative sign, and that is negative, and one negative sign, negative. The function derivative is negative. And in the last one, it is positive. So clearly, we have two intervals. Those are from minus 4 to 0 and from 0 to 4, where the function's derivative is less than 0 or negative. And therefore, the function is decreasing in these two intervals. We can write down our answer that the decreasing interval for the function is from minus 4 to 0 and from 0 to 4. It is important to note that 0 is not included in our solution, correct? Because we know that x is not equal to 0. It is a restriction on the rational function. So it is also a very good idea to begin with writing the rational function's restriction and then the solution. Is that clear to you, sir? Very good. So based on this, we have the next example, which is the real question you asked, right? So we want to find the decreasing interval for the function square root of x plus 4 over square root of x. Now, let's find the derivative. We'll adopt the same process which we did for first three parts, correct? We could always write the function as x to the power of half, right? You could write this as x to the power of half plus 4 into x to the power of minus half to write down the derivative. Now, you know, square root of x derivative is half times x to the power of minus half. So you get the first term. The second term, minus half, 4 times minus half, you get negative sign, and 2 in denominator, x to the power of minus half minus 1 gives you minus 3 by 2. So that becomes the derivative of the second part. Is this clear to you, Asad? Right. Now, at this stage, it is very important to understand how do we factor and write the equation in the factored form. You see, x to the power of minus 3 by 2 is the lower power. So I can take that as a common factor. Also, half is a common factor. Do you see that? I purposely did not write 4 over 2 as 2 because, you know, I could have taken half outside, and that is why I didn't simplify it earlier. Do you see that part? Correct? Now you can say half and x to the power of minus 3 by 2 is a common factor. If I take x to the power of minus 3 by 2 outside, then x minus half becomes x, because if I divide minus half by x to the power of minus 3 by 2, I get what? I get minus half plus 3 by 2, right? Which is equal to what? 2 by 2, which is 1. And so we get x here. And in the later half, we have taken x this as a common factor, so we are left with 4. So we have x minus 4 as the other factor in the given equation, and therefore the derivative can now be written in the factored form. F dash x is equals to half of x to the power of minus 3 by 2 times x minus 4, correct? Now from this factored form, we can write down the critical numbers. One critical number from the first factor is x equals to 0, and from the other factor, it is x equals to 4, correct? So those are the two critical numbers. Remember, in this equation also, x is not equal to 0, right? In fact, x has to be greater than 0 because square root is not valid otherwise. So therefore, the domain is that x should be greater than 0, correct? So that is what I've written here as a note, that the domain of the function is x is greater than 0. And that makes it very interesting. Now, when we have the critical numbers, which are for us 0, x equals to 0, and x equals to 4, the intervals which we are interested in are only two. One is from 0 to 4, and the other one from 4 to infinity. because you cannot test the interval on the left side of 0. And therefore, I have written that this interval on the left side is not valid because it is not in the domain, right?
Mhm.
Square root of x, right,
Yeah.
is only possible when x is greater than or equal to 0. However, we have 1 over square root of x. That means x is greater than 0. We cannot put x equals to 0 also, correct? So that brings us to the domain of the function. So we have to be very cautious about the domain while treating the function or analyzing its derivatives, correct? So
Mhm.
I've taken the two intervals this time, and these two intervals are from 0 to 4 and from 4 to infinity. The two test points I've taken as like 1 and 9, you can see. 1 and 9 mainly because in this interval, square root of 9 is 3. It is easy to calculate, correct? So use the values which are easy to calculate. That's another very important thing. So once you have 1 and 9, we know x to the power of minus 3 by 2. A radical function with a positive value of x is always positive. So we get positive values for both the intervals. However, the factor x minus 4 is negative when x is equals to 1 and is positive when x is equals to 9. And therefore, we get negative and positive values. Now, when you multiply these two, we get the derivative of the function. So the derivative of the function can now be written as positive for the interval which is beyond 4, but it is negative when we have the value between 0 and 4, since we are multiplying a value which is positive and another which is negative. Well, division is same as multiplication, therefore I'm using this word multiplying. So therefore, the decreasing interval will be from 0 to 4 as mentioned here. You see that part.
Mhm.
Now 4 is in the domain, and therefore I have included 4 in the answer. So the square brackets for 4 and a curly bracket and the open bracket with O indicates with 0 indicates open bracket 0 not included, correct? So that is how you're going to answer this question. Is this absolutely clear to you, Asad?
Yes.
Okay, can you summarize your learnings? How will you solve such a question?
So for this question, I would begin by finding the derivative of
Mhm.
the function that's
Yes,
given. And after I get the function, I'll try and get the critical numbers.
yes,
Um, and when I get the critical numbers, I'll then use the the derivative that I found, right? And
yes,
I'll start putting in testing points
yes,
within the given range from
correct,
0 to 4.
yes,
And I'll be plugging in the numbers for that and looking at the signs, whether it's positive or negative.
correct,
And then as I build my table,
yeah,
I'll multiply the values. So positive by negative, I get negative,
yes,
and the negative means it's decreasing. So that's what I want. I want that
correct.
interval. And yeah.
Perfect. That is how you're going to do it, right? So this is called the interval test, which we perform for the first derivative. You have also seen for solving inequalities. This is what we do, right? So yeah, exactly the same process. So that is how you do it. Now here, let me summarize both the solutions with the help of a graph. 1 over x and x plus 1 over x is a graph which is shown here. You find that decreasing interval is from here to there. Do you see the decreasing interval? So these are the two
Mhm.
decreasing intervals which we found. Do you see that?
Yeah.
These are the two decreasing intervals. Now, since the first derivative was 0 at this particular point, right, or undefined, 0 in this particular point, we do have a local minimum also. This one gives you the local minimum, and that gives you the local maximum, correct? So, as you can see from the graph, we did find decreasing interval. In the second graph, the domain is restricted. So, we have a function which is decreasing in the interval as shown here and calculated in our calculations. Do you see the graph and correlate? How does the function looks like? It's always a good idea. When you're using a graphing calculator, once you've done the calculation, plug in the function and see how does the graph look like and correlate it with your answers and register all these things. Since in curve sketching, they are going to be a very important part. Is that clear to you? So it is like, how do
Mhm.
we apply today's learning in tomorrow's lesson, right?
Mhm.
Now, let me take the second example, which is uh, question number 2. The function y equals to x squared plus bx plus 10 is increasing in the interval minus 2 to 2. Find a possible value of b. So we need to find the value of b for this particular function. Now clearly, x squared positive coefficient means a parabola which is opening upwards, correct? Now we are saying increasing in a very small interval, right? But it begins with -2, right? That means that we are looking for a point which is -2 here, right? And since we are increasing, we are looking from this -2 to infinity. In fact, -2 to infinitely large value is what we are looking at. So basically, the interval from -2 to 2, which will be like this much, correct? For example, will be included in that bigger interval, correct? It is a subset of the bigger interval. So basically, we need to find the value of b where the axis is at -2. Is that clear to you?
Mhm.
Without calculus also, you could use the formula minus b by 2a and find this answer. However, it is just an example. We could have another function which could be more complicated, and therefore we are going to follow the first derivative analysis to answer this question. So important thing to remember here is that we can find the axis of symmetry point where the derivative is 0. Since the leading coefficient is positive, the function represents a parabola opening upwards with increasing interval to the right side of x equals to -2, right?
Mhm.
So let's find the derivative of this function. Derivative of x squared plus bx plus 10 is 2x plus b. Now, increasing means this derivative should be greater than equal to 0. And we can now solve b is greater than equal to -2x. We are given a value of x. The lower bound is -2. So I substituted this value of -2 for x, correct? So when I do -2 times -2, I get the value of b as 4. So the value of b could be 4 or more than 4, correct? Because
Mhm.
even if I have a parabola, which is kind of like this, for example, in that case also, the interval from -2 to 2 will be increasing, correct? So I could have any
Mhm.
value of b, which could be 4 or more than 4, correct? And that is how we get one of the values, or we can get many values of b. So that is how we could solve such a question. Is that clear to you?
Mhm. Yes.
Okay, so I think we've done both the examples. I will. So I hope you understand. Uh, well, Asar, I'd like you to summarize today's learnings to end the lesson for the benefit of our viewers. Can you summarize what did you
Mhm.
learn today?
So in today's lesson, we learned how to find the decreasing intervals of a function using the first derivative and also using minus b over 2a.
Yeah,
And yeah.
great. So minus b by 2a was a technique which you could have used without even using calculus, but that is only valid for parabolas, right? Increasing
Mhm.
intervals. However, when we have a more complicated function, as we did for radical functions, in that case, the derivative is a very good way of finding increasing and decreasing interval. It is very important to note that this concept of increasing and decreasing interval is very helpful in curve sketching and in also finding the local maximum and minimum for a function. So I hope that will be for the benefit of many of our viewers. So Asad, thanks a lot for sharing this question, and I
Mhm.
hope my viewers will definitely benefit for it. Thank you. Let's end
Mhm.
the class here.
Thank you,
Okay,
Mr. Anil.
have a great day.
Mhm. You too, Mr. Anil.
See you.
Bye.
Bye.